PHYS 2212 Lab 2 Charge Tape Revisited. Introduction. The purpose of this lab was to create a computational model of the experiment conducted in Lab 1. Then we would visualize the distributed electrical force on the tape compared to the gravitational force. The findings were that the original charge of the tape was 9.33 times 10 to the negative 9 newtons per coulomb, and the magnitude of the electric force was 3.343 times 10 to the negative 4 newtons, and the magnitude of the gravitational force was 1.962 times 10 to the negative 3 newtons. And the new computational method estimates the charge to be about 3.343 times 10 to the negative 9 newtons per coulomb. Coulomb's law states that the force placed on an object from an electrical force is based on the Coulomb constant multiplied by two charges and divided by the distance between the two charges squared. Superposition principle also states that the individual forces can be summed to find the net force on an object. This, along with the Newton's second law, are the key concepts for this lab. Model. Assumptions that we'll need to take is that the assumption that each tape is the same charge is evenly distributed, and we ignore error resistance and treat each tape as a point charge. Except in this computational model, we won't be treating the top as a point charge, but as a series of point charges across the tape. And this scenario is that we hold the both charged tapes together, measure displacement of tape B, and then balance force from electric field with gravity to find the charges on each tape. Experiment. Transfer electrons to another tape by sticking two pieces together and ripping one off. Hang the newly charged piece of tape off the ground with the sides attached to two tall objects. Create another piece of charged tape and hold it on the other charged tape. Record the displacement of the hanging tape. And then here's the code to make the new computational model. And here is the results. As you can see, we have the magnitude of electric force being 3.32 e to the negative 4, and the magnitude of gravitational force being 1.962 e to the negative 3. And the possible sources of error for this experiment were that the electrons were transferred through the fingers when conducting the experiment, the electrons transferred through the surface that the tape was attached to during the experiment, and forces other than gravity that affected the tape. These things could have possibly affected the charge of the tape and how it changed over time, or the distance between the two tapes that was recorded. Conclusion. What if you had modeled each of your tapes as a single point charge like in the previous lab? If we used a single point charge, we would have calculated the same point charge Q that was calculated last week in the model that would reflect the point charge instead of a distributed charge. Why do these estimates differ? Which value is more likely to be closer to the real value and why? These estimates have different sets of parameters and assumptions made, so derived values will be different. The new charge estimation of Q is most likely the closest to the real charge of the tape. Thank you.